looking at, I am looking today that we are turning in. Yesterday we didn't turn in, but today we will turn in, and you'll do it a little later in class, and I'll give you scissors. We are going to be turning in the D11. The reason we're not turning in D12 is because on the back of it is 13, and so today until we get that part in. Okay? So, looking at number 7. As we look at number 7.
I had my book this morning.
Do you want to go check one? Leave it someplace? I don't know.
Right there. This is my notebook.
Go check. Go check. So, taking a look, number 7. I look at 3, 6, and 7. The least common multiple of 3, 6, and 7 should be 42. So when I go to multiply, I need to take 42 over 1 times. Please rewrite and put the x in the numerator. So write it as 2x over 3. It is then a minus 1/6 times 42 over 1 equals 2/7 times 42 over 1. So we're going to start simplifying. 3 goes into 42 how many times? 14? Okay, so 14 times 2x. Haley, I'm going to write down how much? 28x. 6 goes into 42 7 times. So Sophie, I'm going to write down minus 7. Equals 7 goes into 42. Bergen, how many times? 6. So Greta, I'm going to write down 12. And at this point, I'm going to get my 28x by itself, and I do that by adding 7. And you add 7 and you get this really ugly answer, 28x equals 19, and you're almost done. And you just divide by 28, and this is your answer. It's 19 over 28. They're ugly fractions, as you are doing many of these. Some of them work out kind of nice, but a lot of them do not, and you get kind of these ugly answers. It's not wrong when you get that answer. It's just that's how you want to lead your solution as you are looking at that. Okay, so since there weren't other questions, I would like you to turn to your notes to D13. D13. That was yesterday. There wasn't any notes on D12 because it was just like still do. So tonight and tomorrow we'll be working on D13. And as you are looking at this kind of leads us into something we're going to be doing in our next unit. So it says, we're solving for y in certain equations. It's important because it makes it easier, and what we are looking at is that it makes it easier to graph the equation, which is what we are going to be doing in our next unit. So it makes it much easier to graph. It's going to be called our slope-intercept form. And then the other thing that we are looking for in your notes is that we can solve for y or x. And the reason, again, that we're going to do that is that we are looking at writing it in what's called our function form. Okay? So function form, sometimes referred to as slope-intercept form, as we are looking right here. Okay? So I'm going to give you some examples of what function form might look like. So that when we are looking at our equations, we're going to see them in this form. And so if we are looking, we might have something like y equals 2x plus 4. We might have something like y equals negative x minus 8. You could have it with x equaling 5y minus 1. And what you want to notice in all of these equations is that all of our variables are to the first power. All of our variables are to the first power. We don't usually put the power in. It's understood that this is x to the 1. We don't write that this is y to the 1. So all of our exponents or our powers are to the first power, and that makes them linear equations. We're going to be working with graphing linear equations. We do that for, I don't know, it seems like we've been solving this. Doesn't it seem like we've been solving equations for like forever right now? I feel like we've been doing it for almost a month. I don't know if it's been that long, but it's been close. Okay? So we are going to be moving into this next part, and we need to solve for y. So when we are solving for y, if we look at this equation right here, our first goal is to get y divided by 3 by itself. That's our first goal. So goal 1 is to get that y divided by 3 by itself. And then our second goal, when we are asked to get it in y equals form, is to write 1y equals. So my end goal is I want 1y equals when I finish this problem. So if I start out and I'm trying to get rid of the 5x, how I'm going to do that is I'm going to write out the whole equation. I'm going to put 5x plus y over 3. And to get rid of 5x, we would actually subtract 5x. And we're going to do it on both sides of the equal sign. Now, usually I know we have subtracted this 5x kind of right below on each side. That works also. Are 2 and negative 5x, are those like terms? Can we add them together? No. So our justification over here is we are subtracting 5x both sides of the equal.
There's no 5x on the other side equals.
Right here.
It is 0x.
So when I add these two together now, when I add this 5x and this minus 5x, that is now a 0. So when I do that, I could put 0 plus y divided by 3 equals. We can't add those, so we're going to leave it as 2 minus 5x. And now I have y divided by 3. So what I want you to think about is what's the opposite of dividing by 3. The opposite of dividing by 3.
I have a question.
Okay, just wait. Let's go through and do a couple before I get some questions, because you'll see as we're doing these. So the opposite of dividing by 3 is to do what on both sides? Multiply. And we want to multiply everything by 3. So we're going to put multiply everything by 3. That means I'm taking this one times 3 over 1. The 2 I'm just going to take times 3. And that 5x I'm going to take times 3. Here the 3's cancel. Y equals 3 times 2 gives me 6 minus. We don't write it as 5x3. We take the 5 times 3. And 5 times 3 gives us 15x. So when I look at the problem, and I know these look a little weird at first, so just kind of give yourself some time to kind of make sense of this, is as we look at this, we now have y equals by itself. And this was just simplifying. Okay, that was our last step that we did. And a lot of times you might see this answer written in the back. I would accept this for the correct answer, 6 minus 15x. But I would also take it this way, negative 15x plus 6.
Was that one problem?
That's one problem.
That's too many steps.
I know. It's a lot.
Wait,
You can do
I
it.
have a question.
All right.
This makes no sense.
That's okay. It's going to get better. You just got to give it time. Give it some time. What's your question?
Okay, so since we added the negative 5x on that side, is that why we added it on the other side?
Yes.
But why did we have to add it to cancel out the other side?
You're trying, right, to cancel it out. And you'll see that now when we do this next one. So let's go to the next question, and then we'll kind of, what's that? Yeah.
Okay. Can you go back?
Sure.
Okay. So for the 5x minus 5x, isn't there technically a 0x on the other side by the 2? Like
No,
on the-
because there was only a 2 to start with here. So when you take 2 minus 5x, it's just 2 minus 5x. Let's do it in this next one. So let's go on to this one, and you'll kind of see as we do this next problem. So we're going to do a few in practice like this, just like the other ones, okay? So in this problem, we're going to have 2 different problems. Here, we're solving for y. That means I want 1y equals. That's my goal. Over here, we're solving for x. I need 1x equals. So one problem, doing it 2 different ways, getting 2 solutions. In the first one, how do I get the y by itself? Subtract 3x. But do not put the 3x below the 4. Put it way back here, right? Because can you add 4 and 3x together? Does that become 1x? No. It is 4 minus 3x. But on this side, they cancel, and it's 0x. And 0x plus y is really just 0 plus y, which is y equals 4 minus 3x. Now, I will take this as your answer for the question, and you could be done. But if you wanted to write the x term first, Noah, how would I rewrite it? Y equals what? If I wanted to put my x term first. Negative 3x plus 4. And I would accept this answer also. You might be going, well, why would I want to do that? Why does it matter? Because pretty soon we will graph and we will use a special form of equations that you use throughout all of algebra and algebra 2 and into geometry, and you use it all the time, and it's called slope-intercept, and it's a form of graphing. And when you do that, and that's our next unit, we get into with functions, and we graph and slope. So, and when we do that, this form, putting the x term first, gives us some really important information, and putting the number by itself last. I will, in this unit, take either answer. Just know that, okay? If we're solving here for x, my first step is I have to get the 3x by itself. Devin, if I want to get the 3x by itself, I would do what?
You would subtract y.
Subtract y, put your equal sign, put a minus y. As I do that, Daisy, I'm going to have 3x, and this becomes a 0, equals what?
Equals 4 minus 1.
And I'm going to put a 1 in front of y. And my suggestion is that you put a 1 there also. I have 3 times x, but Natalie, I want to know what 1x equals. So what could I do to get a 1 in front of this 3?
Divide it by 3.
And so I'm going to divide every single thing by 3. I leave my answer looking like this. Y equals 4/3 minus 1/3 y. Done. I have 1x equals. That was my goal to start out with. So today, half the homework asks you to solve for the y, and then there's like 5 questions that ask you to solve for x. Okay?
How do you do it? Is it always going to be x and y, or is it
And then when we get in on Friday's assignment, we do literal equations, and literal equations are formulas. And so formulas, have lots of variables in them sometimes. That's when we're going to solve for other things besides y and x. The reason we solve for y and x is they are really important when we go into our next unit of algebra and graphing and slope-intercept and all that kind of stuff. So both of these, you're going to solve for y. if I was starting, so my first step, I want you to think of this. Step 1, you want to add or subtract to get y by itself. That's my first step. So start trying this, because I'm going to have people come up and do this on the board. Step 2 is going to be, you're going to either multiply or divide to find 1y equals, because that's my final goal. So try it right now. We solved this one subtracting the 3x divided by 5. We now want to get 1/4 y by itself. Brooke, tell me what you think I should be doing to get the 1/4 y by itself. Subtract 3. Milk, when I subtract 3 on both sides, I have 1/4 y equals what?
Negative 4x minus 3.
Yes. Isn't it negative 7x? Can I put negative 7? Can I add them together? No, not like terms. Okay, Adam, you are looking at it, and I don't want 1/4 out in front of here. What would I need to multiply everything by to get rid of 1/4? I could, well, if I multiply 1/4, I'm going to get 1 by its reciprocal. I'm going to multiply by 4 over 1. I'm going to take this negative 4 times 4, and I'm going to take this 3 back here times 4. I'm multiplying every single thing by 4, okay? When I do that, Kennedy, we're left with y, and now we're going to multiply these two together. So 4 times negative 4 gives us negative 16x. Then I have a minus, and I'm taking 3 times 4, which gives me a negative 12. Y equals Sammy question.
Can't you times by 4 before you do anything else?
You could, but I have people making many more mistakes if they don't, if you can think of, kind of like when we move our variables first, it wouldn't be wrong, you can do it that way, it's just that sometimes more mistakes happen, okay? So the question is, could I have multiplied here every single thing here by 4 so that I have y plus 12 equals negative 16x? That works too, right? That is definitely going to work. And if I would have started multiplying everything by 4 and had y plus 12 equals negative 16x, am I going to get the same answer when I subtract 12? I'm still going to get the same answer by minusing 12 on both sides, right? So yes, both ways definitely work, okay? I want you right now to look at solving just for x. And when we solve this one for x, my hint is we don't want to subtract 2y. So, hey, we're going to start with adding x on both sides. Why do I want to add x? Because a lot of you are such positive people and you always forget the negative. So, if I add x, I'm now going to have 2y. You thought it was funny, huh? Every now and then.
You guys are such positive people.
Wait,
Oh, that's a good one.
That's kind of negative, though.
when you do these, kind of cheesy.
Kind of cheesy. That's what I am. Kind of cheesy. Yes, that's all right. I can take it.
That's so negative.
Positive, positive.
Nope, it's really negative.
Okay, Kennedy.
So when we do these, we can't have any negative, like, letters.
Well, when we solve for x, my goal is always to have one x, and I want it positive. Now, I will tell you that if a lot of people subtract 2y here, when they bring this down, they just put x equals, and they forget this negative out in front. So that's why I suggest adding it, and now just subtract 8 from both sides, right? So that I'm still going to get x equals. And here now I have either 2y minus 8, and sometimes I'll have people write that as x equals negative 8 plus 2y. Is that the same thing? Yeah, negative in front of the 8, okay? So just remember, you can add either way when you're doing this one. Last one has distributive property. So Greta, start us out. We have 14x plus 3 equals 20 minus 4y. I am solving for x. Next step as you look at it. What are we gonna do, Bergen?
Add the negative.
Well, I could, but I wanna get 14x totally by itself. So if I was trying to get rid of the y, but I wanna get this 14x all by itself. Subtract what?
Negative.
I'm gonna subtract the 3, right? And I'm gonna do it right below 20. Does that make sense? These are like terms. So Christelle, what do you got when I do that?
14x plus, I mean,
Equal.
14x equals 17 minus 4y.
It's ugly. I wish it were not that ugly. It's an ugly problem. You're gonna divide every single thing by 14. And x equals 17. I know, but it didn't ask you. It said here solve for x. Okay? The top two were solved for y, the bottom two were solved for x. Minus, can we simplify 4 over 14?
Yes, 2
2 goes into both of them. 2y over 7. Now, I will not, I'd probably take off a half point if you didn't simplify, but I will be looking for you to simplify. Okay? So, one last, and then we're going to get you started on practice problems. Why are we doing problems like this? Because I like to torture you. Yes, that's the main reason. So, it says this menu, they list outside the store, $10 for pizzas, $5 for sandwiches, and you are going to spend $80. And the question is, how many sandwiches can you buy if you get 3 pizzas and if you get 6? So we're going to rewrite this equation, 10x plus 5y equals 80. Remember, x is the number of pizzas and y is our sandwiches. So we want to solve this for y. Daisy, what would you do first to solve for y?
We're going to subtract 10x on both sides and equal signs.
And when I do that, Robin, I'm going to have 5y equals. Do it with us, right?
5y equals 80.
80. Yep.
Minus 10x.
Nice. Natalie, what are you going to do next to solve for y?
Use the 5.
Yes, you do. Everything by 5. So you need to take out your calculator. You could for 80 divided by 5. And some of you might know that. It is 16. And then you're going to take 10 and divide it by 5, which gives us 2x. Well, minus 2, or if you have plus a negative, okay? Now, the question said, okay, we need to know when x equals 3. So when x equals 3 pizzas, the question is, how many sandwiches? So you are now going to go to this equation and plug in, instead of x, you're going to write 16 minus 2 times 3, because we had 3 pizzas. Which gives us 16 minus 6, which means we can get 10 sandwiches. So, because this is going to be, because we said we get to spend $80, and so this is how we decided to split it up. We got 3 pizzas, we could get 10 sandwiches, okay? It now says, well, what if you get 6 pizzas? So the only thing different here now is that x equals 6. Y equals, same equation, 16 minus 2. But now instead of x, we're plugging in 6. So 16 minus 12 means that we can have 4 sandwiches, right? 16 minus 4, or 16 minus 12 equals equals 4, right? 4 sandwiches, this one was 10 sandwiches, okay? Tomorrow, you do the first, you're doing this 13A, it is 2 pages. I know it's Wednesday night, some of you got busy Wednesday nights with church or whatever else you have going on. I want to look at, do you think number 1 you guys can get looking at this?
Most likely probably
yeah.
not.
One step, right? Number 1 only has 1 step to do to get the y by itself. Okay? Do it right now. Do it right now in your paper. And then let's look at number 11. Okay? Do number 1. What's your 1 step to get y by itself? 1 step. Jordan, what would you do to get y by itself in number 1?
5 minus x, and you bring
So you mean subtract 5x on both sides of the equal?
yeah, and then you
Yes. And I'm pretty much done, right? My answer, 6 minus 5x. If you want to get in the habit of trying to write it in the algebraic form of the variable first, you would have had negative 5x plus 6. I am okay if you stop at this point. But just know that these two are the same. So look over at number 11. I want to get a positive 1y. Should I subtract 9 or should I add 1y to both sides? So that I can be
Positive.
positive. Thank you, Kennedy. So I am adding 1y because I think many of you will make less mistakes this way. 9 equals 1.5x plus y. What do I do now, Erin, to get this y all by itself? What do I get rid of that's with the y? I'm just calling on you. I haven't called on you today, so I gotta move it around the room. I want to get this y by itself. How? Minus 1.5x. Now, that is not going to give me 9 minus, that's not going to give me 7.5. It's going to be 9 minus 1.5x equals y. Answers are in the back, so you can check this, okay? Tomorrow in class, we will have a quiz. It'll have 1 decimal question, like that's on 12, and it'll have 1 fraction question, like that was on worksheet 12 that was due for today, okay? Or if you look back at 11, okay? So, as you are looking at those,